Okay, so last session, myself and Mageta and I, I was undecided between myself and Mageta, and then I said myself. Mageta and I, we started doing the prelude because we wanted to see if the entire pipeline works, but we don't have any functions, right? We don't have functions that we can define because we don't know how to parse those yet. And we also don't have native functions, so we decided to make native functions. And then we struggled to remember how to do that. Then we saw the value one, and then we decided, okay, we need to make three preludes, right? Because we need to make one for the evaluator, another one for the typer, and another one for the kinder. Because these are all native, right? So we decided to do the plus, the minus, the multiplication, and the print.
Wait. Like, isn't the environment of, like, how can I say? Um, when you are type checking stuff, isn't the same environment that has like the types and the kinds?
The answer for that is no.
Can you show me the type for our environment?
Yeah. Okay, so this is the our environment for type checking.
So it has both. So the way you do is to construct the initial one, you call both preludes, right?
Yeah.
Okay, I see.
Yeah. So and then we're gonna hit. We had I think two problems, right? We had the problem with arithmetic native functions. We're gonna go that shortly, and we also had the problem of defining the type of show. That these are is
Wait. Can you repeat that?
Yeah. So we had two main problems that we kind of didn't solve it properly last time. The first one is how to make arithmetic functions, right?
Really?
Especially in the case of binary ones. I'm going to explain this a little bit further on the line. And the
But
second problem was what is the type of show?
okay.
And then we added a draft, like a guess of what we think, or at least what we thought it made sense to be the type of show. But anyway, I want to go first to the arithmetic native function. So we
Wait, let me just try to understand something, man.
go.
Can you tell me what the kinder prelude is?
It's the prelude of kinds for the kind
And
checking,
why do you need that?
because we need that.
You need that.
Yeah.
Uh, I don't think you do.
Well, we just
So,
followed the type checking process, and then we saw, oh, we have something for kinds and for types.
yeah, but take a look. Why do we need, uh, let's, yeah, why do we need types in our initial env for typing, right? Why do we need that?
Because there's no other way that the typer will be able to tell that this symbol has this type.
No, yeah, but why do we need that, right?
Uh,
It's because those ones will be present at runtime with native functions, right?
yes.
Okay. Now, what about kinds? Kinds, they only serve for the purpose of telling the uh, let me see, they describe types, but the ones that are in the context are only type variables, right? Uh, yeah, because take a look, you give it a type and then you say it's kind, right?
Yeah.
But the environment that carry those kinds, they are a map of a type variable to a kind, right?
Yeah.
So it doesn't involve any type that is not a type variable.
Oh, I see what you mean. So if you're not
And
introducing in the prelude something that is a like a native, a very in double quotes, right? Native type variable. I don't think we need.
Yeah, that I don't think it makes sense, right? So yeah, because what would happen is you would ask the type of plus, and then he would give you the T arrow, and we know how to get its kind.
Yeah, now that you said, yeah, that makes sense. The having the type, you already can like deduce the kind by the kind checking whatever.
Yeah.
Yeah, but this is the least of our problems. Removing this is the least of our problems. What is the problem is their arithmetic native, right? Because if you take a
Okay.
look, the native function assumes currying, right? Because you can have a function that
As
takes two
we
values and
have.
returns a result. No, we never had. This is the first time we were actually interacting with the data type value. By the way, we never had to
Oh
care about this
yeah,
before.
but I mean we have current on
No, yeah,
our.
no, but that's important. I'm not complaining. I'm just saying the native function is assuming currying, which is fine, right? It's kind of hellish now that we have this, or the other one. We are actually using results before, but that doesn't matter. Um, it's actually kind of hellish because we have to keep unwrapping this guy all the time. But let's just keep going. So we want to make the arithmetic native function plus, right? So what we thought, right? This is already very very like hacky because we just wanted to make this code work. Where is the code? This code. We just wanted to make this code and this code work. So this is actually non good code at all. So let's go one by one, right? So
Okay.
the initial idea was to make something like this. You pick a function. Uh, Actually, we should rename this to, I don't know, maybe binary arithmetic native. Binary. Yeah, and then you give me the function that you want to do that, like that. Uh, and then we're gonna use the same pattern throughout the entire thing. So that was the initial idea. And then we have oh, this name is to show errors. Then. Okay, so this is why we need the name of the operation. So that's why we had it here also. And then we have the problem, right? So if this value is not a literal, we already throw an error. Cannot operate the name of the operation with all no numbers. That makes sense. But then it starts to go
Wait, wait, wait,
downhill pretty
wait.
quickly.
If what is not a literal?
If the value that you're giving me, because you need
Okay,
to
yeah,
remember that this is we're gonna wrap
yeah,
everything in a
but
v-native function.
oh yeah, but that doesn't even matter, right? It will not happen in practice. But okay, let's go.
Yeah, no, but then we're gonna get the warning of non-exhaustive pattern matching. Anyway, so then it starts to go downhill pretty quickly because then we need to pick this literal, right? This v literal. This v literal can be a bunch of things. It can be an integer, it can be a rational, it can be a unit, it can be a bool, right?
All
Um,
the ones that you have there, right?
yeah, exactly. So we pick and that's something to be aware, right? If we want to make this function reusable, we need to tackle integers, and rational. So everything that we do for integer, we need to replicate for rational later.
Good. Just yeah, just something. You say that because you want some operations that works on integers and rationals, or just for the make of this like boilerplate function?
No, I'm talking if we want to reuse the binary arithmetic native for both operations with L integers and operation with L rationals.
Oh, okay, I see.
If we want that, we're going to have to duplicate some code out of the gate.
Oh, okay.
But let's go with integer just to make my point here. So we pattern match integer, and everything else is we say it's an error. And then that's fine, right? Because if this is an integer, if this pattern matches, we know that the first one of the plus function, the first number provided to the plus function, we know that it is an integer, which is great. But there's a problem, right? We need to the function of summing two things up requires another guy before returning the result, right? It requires this middle guy here. Then what we do, right? We pick and create another vnative function, right? Because we need, this is how we can
Uh,
query stuff. And
yes.
then this is another pattern matching, which we're gonna have to do exhaustively again, right? For all the other ones, we didn't do because again, we just wanted to see this thing working.
Okay.
And then, we now discovered that the second one is also an L integer. And then there's again here for rational is integers, and here again for rationals and integers, and here for everything else that is not literals.
Okay.
And then, if those things are integers, then we just apply the operation to both of them. In this case, it's going to be the function plus. Then we wrap those in integer, wrap that again into the literal, and then wrap that again
No, I can't see.
with the result whatever thing.
So that looks almost right, Levels. But tell me, what is the thing that is a problem slash is not working on?
For me, what is very, very bad is the fact that we have to do a lot of code replication to account for, we have integers and rationals, and we have to do this pattern matching here also.
Yeah,
That sucks.
yeah, it does.
Yeah, so then we left at that. We left at that. But
Yeah, but
then,
we need to do a step back before that, man.
okay, so
Of
just go ahead.
course, I don't think that. Well, let me just read this again. Uh, here.
And before you read, I need to explain why we are using return or peer, and I need to explain what is fail. So, because Magetta wanted to make a print function, this make the entire thing very hellish. Because
Hello.
then we had to tackle. Oh,
Hello,
hello, Magetta.
Magenta.
Then we had to tackle the fact that we don't have any I/O in our stuff, right? But we want to do a print, right? So then I suggested to do the transformer way, but then we
Fucking
discovered that to
Haskell, man.
sorry? Oh, Haskell. Okay.
Fucking Haskell.
And then, but then uh, I thought about it offline, and I actually already made this change because it's already compiling. It was already compiling, right? Now that I added this, it will not compile anymore. But this thing, which is now here, lives here. This allows us to do the I/O stuff when we need. When you don't need, you just forget about it. You don't have to care. But this guys allows us to do I/O stuff and continue having the either abstraction. So that is the only thing that I changed, and now we don't have uncipher from I/O in here, which is great. And we do have a print function.
Why is
But
it great, man? It doesn't matter. No, it doesn't.
It does. It does.
No, it doesn't.
We need to go
That's
back
a
to the
lie you tell
Enlightenment
yourself,
side.
man.
Anyway, Nathan, that's all the updates that I have to use. So we need to fix. Our goal today is to make this function properly.
Yeah, yeah. So the first thing we are missing is one vnative function, right?
What we're missing? Sorry.
Yeah. So you see there the curring part on line 54.
Yeah.
You have vnative function,
Yeah.
but you were supposed to have two of those, right?
No, but I have two of those. I have one here and one here.
Ah, shit, that's
Yes.
awful.
Yeah, that's
Yeah.
awful.
That's disgusting. Yeah,
We we
that's
we
wrong.
agree very much actually.
Yeah, yeah, yeah.
Oh,
So
and
what you need?
one second, Maggot, if you want to join the VS Code stuff, the link is already there. Go on,
Let me
Nathan.
get it here.
Okay, so man, please just change that. Like, do the following. You see on line 52,
Yeah. 52
like
here.
you know the third parameter, like just like forget about this shit and do it like after the equals, man. Like because it's so easier to read, I guess. And there you call the vnative function and pass a lambda. Well, at least I think it's easier, right?
Wait, I'm
And that
confused.
way,
What you want to do is to just remove the put the divinity function here?
yeah,
Ah,
do the
okay.
following.
Yeah, that's
Put
fine.
it there after the equal.
Is that all the change that I wanted?
No, that's the first one.
Okay. Because this entire code was a disaster. We just did it.
No, he said that we are missing something to make what we want happen, Magito. That's what he said.
Wait, what do you mean by what you want?
Yeah, you said that we need to backtrack a little bit.
No, yeah, I said, how can I say? This looks almost right, but let's step a little back to see something, right? That was the something to
Oh,
fix it. But I didn't saw that, like, it was working. It was just strange, right?
yeah, okay, done.
So yeah,
Minus.
but now what you need to do is the following, right? You need to delete the third parameter there, and in the native function, you pass a lambda to that, and that you receive the value and pattern match and shit.
Oh, okay, so what you want is to remove this guy, right?
I
So,
don't think it would change the signature.
oh, we don't
Wait,
think it will.
no, no, it does, right?
It
But
does.
yeah, the text, and then
And also, how are we gonna not make the whole rational and integer in this crap not being hell?
that's a second problem. But the pattern match, you need to do the pattern match. Like there is no other way, right?
uh,
Uh, but that's the thing. I don't think you can parameterize some stuff.
no, but I had an idea to fix this, right? Not, I remember talking about this with
Like
Mageto.
passing a function that does
No,
pattern
no,
match.
no. Just adding instead of having these two abstractions separately, we make one that unites them.
Yeah.
What do you mean
Oh,
by that?
can't we do one?
Not this. This.
Let me think here.
Yeah, do something like data number.
Oh, dude, can't we do? Oh, we could try passing
And then this guy
the construct.
disappears, and we just put L number.
Yeah, that's something we can try doing. I don't know how much this would help though. Passing the like integer or rational whatever as a
Yeah,
parameter.
that's not the real problem, I guess, Lemos. The real problem is how you model that into the language, man. Like, for example, right now what we have is normal types, right? So we have normal simple types, and we also have the for all, right? So we can work with generic types, but we don't have any kind of way to do the ad hoc polymorphism or that kind of stuff, right? Of
Mm-hmm.
rate overloading. So I guess we could like how do I say that? Ah, I forgot how to say that, but to do in a fixed manner for a plus to work with like integers and rationals. But then we have some stuff, right? Because then he has more than one type, I guess, right? You would have the two types, the int to int to int, and the rational to rational to rational. So that's a bit weird. What happens when you ask like his type, right?
Mm-hmm.
But yeah, I think we could do it, but maybe it will bring some strange things that I don't know. I don't know much about.
Oh, and there's another problem. Now I remember why this is not compiling anymore when you do like that. It's because you need to wrap that again with the L integer.
Yes.
And then
So
when you do that, it's going to go, oh, L integer needs to have an integer on the right side. But
yeah.
hey, this thing is not a function that is applied to integers. It's a function that is applied to A's. And then
But
it starts complaining all over the place.
Lamus, regarding like your use of this binary arithmetic native, I guess you could abstract over the fact it's an integer or a rational just for the sake of like templating, right? But I'm not sure how to do it, and maybe it would
Why
be weird. Maybe you
why
would need to
don't
receive a
we?
function that does pattern match and
Yeah,
return
that's what
some
I was going
shit.
to say. Yeah, but why don't we do? we just give up and do this?
Where are you?
Up here.
Oh, up here. Okay. No, 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 not this, not that.
Perfect.
Yeah, how do we deal with plus being used for both? How do we do that? So the first thing is when we
One
are.
one thing I was thinking, and I don't know if I'm right on this thinking. You can correct me, Nathan. I was thinking, can we use a type variable to pass the thing we want, abstracting over a function?
I'm not sure what you mean.
You mean passing
Uh,
integer
like a
to a
for
function?
all, yes, like as in a for all, but passing the type that you want to apply.
Can you like write some?
Let me think. So, oh, we have an examples. Let me go here. Functions.
Oh, just a second. So yeah, I just saw them. We are using those as functions, right? So maybe that's on our error. Maybe we should do them as operators, even though like it's not a Lisp stuff, but we can have a special node in the AST, and that one we can treat that differently, in the sense that he will be able to use to do both, like integer addition and rationals, right? In the type check of this, we permit both types and do the sum there, right, in different ways.
Wait, so you're suggesting adding another guy to this?
Ah, mm, no, not to this. Wait. Actually, I'm not sure.
And I don't know how this would work.
Oh, that's not there on the values. It's on the ST, I guess. Like
Okay.
if, but let's go with Magenta thing first, because
Actually, I don't know how that would work. But my idea was to think like, because what is our problem? Let me go back here. So what is our problem? Our problem is it's not really Haskell, right? Haskell we can solve with the type classes.
No, it's not Haskell the problem. The problem
The
is
problem
something the
is
modeling.
how. Yeah, but here's the thing. What are the components that are necessary here? It needs to be a literal, and the literal has some cases.
Yeah. And then
And
there's a
then,
second problem, which is when we do currying, we need to pattern match again.
yes, exactly.
And then there's a third problem, which is that when we need to wrap the thing back, we would have to, and then this thing will be bounded. It cannot be generic anymore, like in here.
Hmm.
Oh man. Wait, I think that the third problem has a solution. One sec.
The third problem, let me see
Yeah,
what
the
you're
third
doing.
problem is about having having
The inference restricting the number. Is that it?
no, I am thinking about applying a from integral function to the whatever result of this guy.
And what is the from integral?
So this is when we have to do some sort of conversions of like one number type to another number type. So when you have an integral and you need to have something else, you
Oh,
just call for integral usually.
but that's bad, isn't it? Oh, actually, dude, like this function is quite function is not that good, I think, because okay, like if we're gonna support like other types and overloading on the plus, how would that work?
yeah, I suppose. I think that going the plus as a function route, it just like will screw us over. Like I don't think we have a way to do the overloading without like implementing the other things for the future, right? I think as an operator it might like work, I guess.
Okay, so what would be the difference between a native function and a native operator?
So let's do it. Well, it's not a native operator, it's just an
Yeah.
operator.
No, but
Go to the
I
AST.
think we would have to
Oh,
separate
we
those in the
add on
node.
the ST the type for that. The the thing is that it, Nata?
Yeah, like let's go there. Let's try to do it.
Okay, so if you go to the AST,
But
So
where?
yeah,
That's the
there
question.
you add what you want. It could be like a node for
It should be a value, isn't it?
no,
No.
it's an expression, yeah. So you can do the following. You can either do like just a
Oh
node
no, no, that does make sense. That's right.
for a sum, or
No,
you can
wait.
do
Now I
like
am the
a,
one that is confused. How that's not a value?
No,
yeah,
because
let's
yeah, because the value of that is the operation, right? You process the thing and then you spit the thing. It doesn't represent a value in itself.
I'm confused.
Like
like
for example
values.
here, op sum. Actually, let's do operation, and
No,
then
E
we pick
operator I think it's better.
operator. Okay, but then what do we pick here?
Yeah,
We pick.
operator says a different
Okay,
thing.
I was thinking of a list, but let's first do the just two values, okay? Just to be easier. So it takes another expression, right?
I guess so. That makes sense.
And another expression. Let's just do with two for now. And then this thing, when you evaluate, we need some sort of type here. I'll just put text for now, but this should be the label for it that we put in here. But imagine this is another thing that is the type, like we did with the Latin, I guess.
Oh, so this is gonna be the way to parameterize the type?
Yeah, like not really,
That's a bad take.
not really. Like, uh,
You could do the following. That will be easier to understand. Instead of e operator, you can call that operation or binary operation to be more precise. And text you substitute by operator.
yeah,
Okay,
okay. I
okay.
just
That is a new
I'll
data
just leave
type.
text because I don't want to make the new data type.
No, no, no. But then it's
Uh,
gonna be text. If this
dude,
is an
okay.
operation,
I
it's
just
fine.
want to explain the thing.
No,
Just
go.
wait.
Just go.
So and then from this thing we get a type specific for this thing, which is not a type annotation. That's a different thing. So that's what I'm saying. And this thing here evolves to a value that is not like a plus or something. It doesn't make sense to evolve to a sum, right? It will evolve to the computation of this thing.
Yeah,
Did
but
you
then
get this part?
I'm okay. Continue. I'm asking how we're gonna do
Okay,
that.
let's do it. I think I get the idea. Where did you do the Latin? Where was that?
No, but I don't think we need to fix this. In the operation, I think it needs to go in.
Okay, that's what I'm doing, man. Let's sort. Where's this shit? Here. So this is the same thing. Operator sort, something like this. Or just operator. Plus, minus, and let's just do those two. Then we pick those. I don't know if there is any impediment for us to do a list here.
Yeah, that's a really good idea, maybe.
I don't think there is because we were halted from using a list on the other thing because of the currying, I think.
Because they are functions, right? But
Yeah.
now I don't think we have a reason.
Yes, I don't think, and that's actually good because we can do like Lisp. So
Yeah, but then we're gonna have
At
to.
least only for for operator, right? But that's already really good.
We're
Because
gonna have
well,
to.
for some,
But then wait. Then we're gonna have to parse operators in a different way because they are not e
yes,
variables anymore.
yeah, if you get a
yes.
variable there and it is a
Now,
plus, then it's
yeah,
an operator.
and we're gonna have to add a special case for this.
Yes.
That
I mean,
sucks.
it's fine. It's still an application, but with an operator, right?
It's not an application anymore.
Yeah, it will conflict with the operation, the application. That's what I mean. Because it will understand this is a variable, so we need to add this case that it escapes this.
Oh yeah, man. That we need to forbid
Yes.
operators as. Oh.
So
Okay.
let's change the grammar already, but let's not lose too much time on this, man. Last time we spent so much time on the grammar. Okay, here. Where's it?
Okay. We're gonna have to go to.
Here,
Oh my god.
expression.
Yeah, expression. Then we're gonna have
So
to
is
have.
this in priority?
No, this is not in priority at all.
Okay. So let's just add one here for an operator.
Yeah.
That is what? The operator takes. Oh, operation, right?
Yes. Yeah. Operation.
Uh, that
But it takes
takes.
an operator, so I'm gonna actually add the operator here. And this is one is easy, just like this.
Let me remember. What are the things the like enclosed expression? What is that thing? That's the opening and closing. Is that it?
Uh, wait.
We can put division here, I
Enclosed,
guess.
it is enclosed expression. Enclosed expression.
I think now we can put division. Okay. And then we pass, and then it's another sheet here, right?
Yeah, this is what
Parameterized.
it is in the middle of the parentheses, the brackets.
Okay, so it is an operator. Oopsie. Oh man, what the heck is wrong with me? Operator. Let me just check a message, just a second, because I need to reply this person.
Okay,
Otherwise, my
so you
life
get an
depends on it.
operator, then you have a bunch of white space, then ooh. Yeah, what comes after? It should go in the numbers, right? But
Yeah, just
our
the values,
no, but
expressions.
oh, expressions. Okay, so it's gonna be a list of expressions. So there's a list stuff.
Yeah, so it is. How do we do the many on this thing?
List expression.
Okay. Mm-hmm.
Is this?
Yeah,
Oh no no
that's
no.
it.
There is no
But
list. You're correct. So you need to do a many. So it's gonna be it is a many that accepts. It needs at least one, right?
yeah, that actually we can just put. I don't know. Like, do we want to do like Lisp, like this is equals to 0?
I hate that. So
I
I
don't
am
think
in the
it is
minority
bad
here.
actually. I don't think it is bad. Like multiplication is with the 1.
Yeah, you are hard coding a monoid into this to the
Dude,
crap.
it would, you know what would be very cool? If we could define these operators.
You mean in the language itself?
Yes, because dude, this would be monoid being supported by default. Yeah, I don't
Well,
know how to do that. We might think about it, but this would be very cool.
I need to agree that it would be very cool to have monoid support, but for now, I think we can just go with the
No, no,
plus to
for
be
now, no.
safe.
Yes, I'm just mentioning because it's a decision, right?
Yeah, this is a
No.
decision. Yeah, but okay, grammar-wise, I think that that's it. So an
Okay,
operation is
so
enclosed with brackets, and it requires an operator separated by spaces to another expression,
okay,
and that's fine.
so let's move this here. I guess this is the place, right, of the basic units.
Yeah, yeah, this is here.
Okay, so let's go back to the AST,
Okay.
and I think that's it. So just a list of expressions and an operator.
Yeah. So let's
If
assume.
we want, uh, I'm thinking now, would we need an annotation, right?
Why?
Well, plus, like, can we add two things? Like, that's the question. Like, for example, let's suppose, I know that in most languages this would make sense, like in even F sharp and whatever. This is valid, right? But this is not the plus we know. This is the concatenation. This is the this, right?
Oh yeah, that's not a problem. We don't need any kind of annotation or type and shit.
So in
Like
this
in
case, we
our
just ignore. Is that it?
um, no, we
Here's what I
can
mean. Like,
just do the operation or get an error.
yeah, no, yes, but that's the thing. Do we want to handle prevent the error or not?
What do you mean by
Like,
that?
evaluate if the thing makes sense. Type
Oh
check
no,
this
but
expression.
he's right,
Well,
Matan. Because if we try to do this, man, like this, and then rational, and then bool,
Yeah,
I think the
that's
type
wrong.
checking will say that this is fine.
no,
Why?
man, it will not.
Why not?
Because we will do the type checking.
Oh, so you want to do the thing that the least. Yeah,
Man,
but okay,
let
but
me.
what I'm
Yeah,
saying
yeah,
here
we
is
can do
that
that.
depending. Here's what I'm saying. Depending on this, it might change the thing.
Yeah,
So how are you gonna know? You are gonna
what
make
if?
a
No, no,
huge
no.
pattern match.
No, it's not a huge pattern matching. It's like this, I get it. We're just gonna pick a list. This, like, let's suppose that the parsing went fine, right? So we parse a bunch of expressions, and then we're gonna dismember the list into something like this, and then we're gonna check the, we do a pattern match on this first. If this first is
Man,
an integer,
forget what I was saying. Like, it doesn't make sense to pass something here, right? With the ST generated by the parser. Like the parser, how is it gonna generate the types for us? Doesn't make sense.
no, that part doesn't make sense, but you are right in the sense of, oh, this is a literal, this is also a literal, and this is also a literal. So all of those are valid expressions. So how are we gonna discover that we are applying, I don't know, plus to booleans? And the answer is that because we are the
Yeah,
ones
that
doing the
is.
type checking, we
Yeah,
can
yeah.
just pattern match the first one of the list of the expressions, and if it's an integer, the fold would have to check that
Yeah.
is, oh, I am applying everything to integers, and so on and
Mm-hmm.
so forth.
Yeah, it's fine then.
Yeah, okay.
Okay, so
Yeah, though my
this.
question, I have a question still. So
Okay.
how does this interact with our evaluation environment? That's my question.
What do you mean
Without
by environment? You mean eval function or the environment itself?
I mean this thing that I'm highlighting on the
Yeah,
prelude.htc.
it will not be there.
It will not be this?
It will not be there.
There? What do you mean? What? What is not going to be there?
You don't have the operator there or something. Therefore, you don't have any interaction, I guess.
Oh, okay. So we are completely set. The E
yeah,
operation will have a separate pattern matching in the
yeah,
eval with
in
environment.
evaluator.
It's
Yes.
a
Yeah,
different node, right,
Uh,
from the
yeah,
ST.
yeah.
let me see here.
And
Where are
there
you
it's
doing
the
that?
fun part where we check if, oh, the values are all
I don't know
strings.
what you
Then
mean
we
by
can do
fun.
concatenation.
What do you mean by fun part exactly?
Well,
Explain
it's
to me.
fun, right?
Explain, please. Where do you mean? What do you mean?
Evaluation.
Okay. Okay. So let's
Yeah,
do
but this is
the.
very weird. Our plus and minus and arithmetic operations, they are not native functions.
No, no, that's
Yeah,
not weird. That's the
that's not.
norm.
Yeah.
Oh,
Lisp
it
is the
is
one
weird
who
for us because we last time we did it in
Yeah.
Erlang.
Last time we didn't do that. Yeah. And that's actually
Lisp,
good that we're
right?
doing this because I think it gets easier to generate the code out of this.
Generate the code?
I don't think it matters much.
Oh, oh, you mean code generation? Oh, yeah, yes.
Okay,
I don't think
so
it matters much, but it's helpful. Okay, so what are the things again? So it is a
Arthritis.
list, right?
I think you
Uh,
just should
are,
do the copy of let in, I guess. Let in or let plus? Is the let plus the one that is accumulative?
I don't know.
I think yes.
What are the types again? I think it is. Oh, let's annotate with another thing because this will be OP, OP minus, OP plus, OP div, OP move. Okay. So can you import those things, Lemos? Not even.
Just one sec. Where are you?
We
Oh,
could
here.
here. Let me think of something here. We could separate even more and do like arithmetic first, which behave like because they all behave like the same, right? So we could make another union here with like arithmetic, and then we check. Okay, is it an arithmetic as an operator? So it just behaves like the rest. You see what I mean?
Can you write that down?
Like they all. Do you agree that they all fold
Yeah.
with different cases, but they all fold, right?
No, but I think they
So
all fold even if they are not arithmetic.
yeah, but we might have not necessarily, right? We can have like a binary operator. Actually, this operator is okay. We left the. Let me just recall here. So we left the print outside, right? So it's still. So it's gonna be a native function.
Yeah, no, the print is going to be a native
What
function.
else? What else could go here? Just yeah, just operators. I guess more than that would be yeah. So all of them would fold.
Yeah, all of them
Yeah.
fold.
Yeah. Okay. So I don't see a problem. So operator only, and then we do.
No, not here. You are here. Okay.
Okay, so then we do a check, but then we need to do a fold again. No, not a fold. We need to do a map. So
Wait, what do you want to do? You are pattern matching if it's an operator, then you
uh,
grab the
yes,
operator, and then you
and then we
update.
Wait,
map the
why don't we
args.
do the easier first? Type checking.
The easier. Oh yeah, the type checking works. Actually, I prefer to do the evaluator, but if you want to do the type checking, that's fine. I
I
think
think I
both are
agree with
the.
Magita that I prefer bottom up.
I think the evaluator is actually easier, man, than a type checking.
But it's because me and Magita we are monkeys. We're not masters like you, Nathan.
Monkeys. Yes, we don't think in the lambda cube. Me monkey. Me like
Okay, so
banana.
case head.
Oh, sorry.
Uh, no problem. Case head of args. Actually, don't need to do like that. We can just, I don't know, x
Uh
this.
huh.
Case.
Isn't it true?
No, it is
Like,
just one.
oh, that's weird. I thought it was
It
like
is the
this.
same as the cons operator.
Mm-hmm.
Case of.
Oh, I see here.
Okay, so if it is.
But doesn't that can
Uh,
be empty?
but one thing, why? Yes, I was going to say that. But why are you separating to begin with?
Because we want to check if the of the first, because the first will determine if we need to like the
Oh
first.
shit, folks, we have a problem. Oh no. So Mageta, take a look. Think about the following.
Mm.
Let's suppose we want to use with integers and with our rationals, right? But well, with things will also be cool. But what happens when we use this plus with an empty list? Will we return which of the default ones? We don't know.
No, wait.
Oh,
No,
we
it's not
do.
possible to have a plus with an empty list because the parser will not allow that to happen.
Oh, so you
Yeah,
forgot
but
about the
even
idea.
even if you allow, that's not a problem, is it? You can
Oh no, no.
It
manage each
is.
kind of operator.
Can you repeat the problem if we allow it to be empty?
Okay, so if we allow the operation to be empty, right, and it works for both integers and rationals, then we don't know what is the default value to be returned.
Oh, that's true. We
Can
would have to have a very stronger compiler
Oh, I see,
to
I see,
figure
I see, I
that
see, I
out.
see. I see the issue because that part of the problem is on the is on here, right?
Yeah, kind
I
of.
have a sketchy solution, I guess,
I
which
want
is
to hear that so much.
let me see.
No, but there's not possible, Mageta, because the only way that I can see that being possible is if we look at the context of that operation in the middle of the
Yes,
code and see,
yes,
oh, this should be an integer. Okay, let's try that.
Yeah, that's probably harder than normal type inference.
yeah.
I don't think we are able to do that.
That is very advanced, I would say.
That's that's very. Never mind, man. Yeah, okay, so ooh,
So
that's
how
a
does
real
it
problem.
happen? We have at least one or at least two,
At least one, I think.
No, it is
and
at
then
least
it
one.
returns
This can be empty.
itself.
This can be empty.
And then, yes, if you add a plus, we can just assume it's always like the neutral thing. Oh, but man, that's still a problem. Like, okay, uh,
Like you return itself, or you do operation with the neutral and this. With the neutral is not a problem.
yes,
And
like
well,
for
it will be
example,
itself actually,
plus.
right? Always.
Yeah, I'm thinking like plus one. Does that has a like plus in a list, right? One, like here. Oh, I don't know
Uh-huh.
why I'm like this. Is this an issue? Because well, we don't know which is the neutral element as well, right?
Well, we know because since we have at least one, we know its type and its neutral element.
Dude,
But I
do
guess,
we have something Haskell like this?
dude, why? No, no, we have the type in the sense of RAST.
Yeah, okay, but I just wanna confirm this to my sketchy
Uh,
solution.
I
I
think that
hope
the
not.
answer is no for that.
So can't you pattern match a type? Like for example, in F sharp you can do this, like ABC with. I think you've seen this, right? Like int.
Dude.
Python City. Uh, I never seen that before. I don't think that's a thing that you can do here.
Yeah,
Java
you're
line.
just yeah, you're just checking what is the type of this garbage.
Just
Yeah,
checking.
yeah, just checking, man. Just
Not
checking.
unsafe at all.
Or we could do this and then get by the type, but that's
Oh
our
my god.
.NET garbage. But like, you can do this. Yeah, this is the same thing used in exceptions, by the way. But anyway, which is the wild card bullshit. But anyway, for exceptions. But here's my idea: if we could know what kind of type it is while checking this garbage. Then when we eval the thing, what is the type of that entire expression here? I know this shouldn't be here, this should be the typer, but then we could decide, right,
Wait.
between,
I'm watching whose screen? Like, just.
I don't know. I'm not sure, so I think it's Lemos.
Oh, Lemos is taking a look at some like crazy stuff. So I distract. But Magenta, you know the type, right? Because since you have the node of the value, you know, like it's the int. So you know.
Oh, dude, yes, Nathan's right. Dude, we're stupid, Lemos.
No,
Oh
no, no.
my
But
god.
I
So
agree with
wait,
Nathan all the way
no
along.
wait, dude, we can.
No, no, no,
So,
no.
dude,
The empty case we can't.
no, we can.
No, we
Oh, the
can't.
empty case we can't.
The empty case we can't because we don't have anything to base ourselves.
Oh, I see. No, okay, that's fine. Okay, so but this one we do,
Yeah,
right?
this one we can.
Okay, that's not an issue then.
Folks, doing the operation with the neutral element in one is always the same thing as just returning the one, right? Or
Yes,
not?
but I'm
Isn't that a
thinking.
monoid law or something?
Yeah, but what about this?
No, no, no. The monoid law is that. Wait. Applying my
Is
pen
an
with.
operation with neutral and one always that one?
I think that is a
Yes,
property of monoids, yes.
So
yes,
yeah,
on
we can just
plus,
return it if it's one.
on the plus monoid, right? Not on the minus
No,
garbage.
no, I guess it's like on the law for the thing, right?
No, I don't know if
No,
minus has a
because
monoid,
dude,
by the way.
Yeah, then it's
yeah,
another problem,
but
not
wait, a monoid is an operation along, right? So it's only valid for plus in that case.
Yeah,
Oh,
That's
I
what I'm saying.
see. I see. We are talking
But it
about
is a
monoids, but not all of our
yeah,
operations are.
exactly.
Oh, I see. I see.
So
yeah, but then how are we gonna separate that?
Oh.
by the way, we are
Because
thinking of
since
operators, but we also have the Boolean garbage, like
I'm
and
gonna
such.
separate
Let's
that.
think of those as well.
oh,
Yeah, like and.
Oops.
Like, does this even make sense? If it is a monoid, yes, right? Because then you have a neutral case for
what's
t.
the behavior with the minus in Lisp, Makita?
Uh, what does Lisp do
Yeah,
with the
for
minus?
minus.
Good question. Let me see.
Like for the empty case and for the
Let's
case with
see.
one.
Como Lisp online.
Looks like you like web browsers.
Yes, I love it. Do you have a problem with it?
No, I love it.
So the minus, it is an invalid thing. It expects parameter, but the plus works with the.
Oh shit!
So
Oh, okay, makes sense, but I was not expecting that.
yes, I wasn't as well. I know that I think the division also follows the same idea.
Wait, is that only common list, man? Because
Well, let's
let
try
me see
Emacs Lisp.
Scheme Online. And you
Emacs.
try the
Oh,
Elise
it's
one.
Lisp.
Dude, what a language.
Dude, there is an Emacs Lisp online because I'm on Windows right now, unfortunately. Um, on Replit. I really wasn't expecting them to do this. Okay, what happens when you do this? So in Lisp, that is zero.
Oh, it's
Like
a neighboring scheme.
in Lisp, this is zero.
Huh.
Which doesn't make any sense, but okay.
Hey, well, you can sort of think of this as a neutral thing. I can understand it. What happens though when you do this
With,
with a
with,
number like one?
yeah, with only one scheme, he just do the negation.
Yes, that's right. But oh, dude, so like actually Emacs is consistent, right? Because if it is zero, then okay. If you are negating, this is the same thing as this, right?
Wait, you are not seeing, are we?
Oh, okay. I'll wait for Lemos to go there.
I don't even know how to works with multiple values in the minus like this.
Okay, okay, okay. Now you can show Magit.
Yeah, like that is analogous to this, right?
That is analogous to this.
Yeah. because
Oh, you
here,
mean that doing as a zero is because when
yeah,
you do, oh man, but that's I wouldn't classify that as a good reason, but that's fine.
oh, dude,
Oh,
it is the same case as a plus. You have the neutral guy, which is zero.
oh.
The only
But
difference from plus is that you're going for the other uh, spectrum, right, of the naturals, but of the integers.
Hmm.
But that's it.
that's not consistent. Do you know why? Because when you have multiple, you're not doing zero minus all the others.
But that's always the case when you're doing plus with all the
But
others.
you're
You are
saying
you're
No,
you're
no,
also
saying
no.
starting
In
from
the
the
case
no, I
of the
zero.
think you're saying
plus,
something like, yeah, I get it. So it's like this. It's not like this, right? Zero minus one, two, three, four.
because if you take a look on the plus, he's doing zero plus like for every one of the list, right? But in the case of the minus, he's not doing zero minus all of those. He's picking the first and then doing the thing.
Yeah, but we're not gonna allow. I at least I'm not a fan of these default monoids for everybody, but especially for the minus and the division. I don't think that's good.
Like we know that zero is impossible. Do we really need the one? Because so far sounds like
Like dude, that's the problem actually in Lisp. That's right, because this is minus 6, right? And this is minus 4.
folks, why don't we do the following? So we accept the thing to be at least two, and then what our operation does is to put the symbols in between. Like you have at least two, and for the list, you got the operator between each of the numbers.
Uh huh.
So that would be more of a like not so weird behavior, I guess.
Yeah, but that we can do. We definitely can do that.
Oh, let me add the booleans as well to the st. Uh, oh, I didn't know you. Oh, this is just the print, right?
Yeah.
Uh,
Oh, I guess that's only bad for one thing. It's when you want to do like something on a list, right? Like,
oh, dude, we need to add lists as well.
That time will come. That time will come.
yeah, it will.
We're literally doing a Lisp without lists. Okay.
Okay. Uh, will the monoid will allow us like will we have the default monoids for and or as well? Because
Uh,
we can.
oh yes, on those two, I think it makes even more sense, right?
Okay. So the and
Yeah, that's right. We don't need to do that for all of them, right?
Yeah.
and the or and okay. So in these cases, because of the monoid law, we're just gonna return the other one,
We need
No,
to.
but
zero
that's
one.
the thing. Like, when you are not overloading the symbol, as in the case of and or, you are not using that for multiple stuff, you can have the empty case
No, but
if you are
we didn't
already
this.
doing
No,
monoid.
but we decided to not do that at the moment, right? We're only
But
gonna do that in
then,
the future.
so you're saying you will accept the one, but not the zero?
Yeah,
Why?
because the zero you cannot decide. Remember?
We can. Like, you cannot when the thing is overloaded, like plus. But and only works with booleans. Then we know the default.
What you're doing, Magita?
I was thinking we can just map this list and mapping this list. We already have everything evolved, and then we just do the operation.
Um. Okay, so what about doing that? I
Okay, this
think
is just an
that's
alias, right?
yeah, but this is should be like this actually. Comes
Oh wait,
before.
that's wrong. X and then here like this, right? And then we do
Remove that, and
okay.
also remove that. I
You need
think these
Is
were
this right?
parentheses in this case.
yes.
Yeah, okay. Yeah.
Yeah, just like
Oops.
that.
Like this. Okay, but then we need to assign this thing to something, but we need to unpack these things that are all monads.
Yeah,
Sorry.
they are all eiters.
Oh man, I'm really dyslexic today. Like I'm saying stuff that
Uh,
I mean something else and I say something else. Like it's just yeah. Anyway, so these are all wrapped in the types they mean.
yeah, but we do
Anyway,
we do have a function to map to handle those called for.
okay.
So the for will take
Uh, we have a problem there also. We don't have short circuiting for the
Yeah,
in
if
the
something
NOR, for
fails,
example.
yeah.
yeah, we don't have short circuiting in this.
And since we have side effects, that's a problem.
Mhm.
It would be like this, and this would be, I don't know, operands.
Yeah, this is the same issue I think we ran on Erlang actually. Because I remember we were doing the same thing. We mapped the list, evaluating, and then we checked after if there was any error.
Well, we
If
could
we
short
saw,
circuit it if we stop using the either and just do an exception. We could.
Why would you need that? You only need to do the following. Instead of using that general one to do the Booleans ones, you use a like a specific one, right? To evaluate them differently.
I didn't get it.
I also didn't.
So you are evaluating an operation in that way to evaluating the whole list and then doing stuff, right?
Mm-hmm.
So you need to evaluate differently in the case of the AND and the OR, because then you will not evaluate all of them at once. Because even if the evaluation didn't fail, but you already know the result, you can short circuit.
Oh,
Yeah,
you
just
mean
to be
pattern
smarter, right?
matching? You mean pattern matching when we know it's
Yeah,
the.
I like to be smarter, right? You do and
I like that how you call it. It's to be smarter.
yeah, like this, like this, but this is false, right? But
uh, okay, so now that we know that the operation is in fact an end, what we do, Anata?
I don't know.
Oh, you don't know.
awesome,
That's cool.
awesome. I
Uh,
mean,
That's Haskell, man.
we could, if it is an end, we can evolve. Let me
oh no,
think.
I know how to
Oh,
do. I know how
we
to do.
just know
Operand
if you find a false, then that's false.
if environment. Then you pass the env. You do the first, and then
Yeah,
uh,
it could be
this needs to
recursive.
be a case operand of e literal. Uh,
Yes, you can just be calling
Yeah,
recursively,
it can be
maybe.
recursive. Yes.
yeah, we're gonna call it a recursive e literal, and then l bool, right? So then you go here l bool, and then false. And if that's the case, you just return we just return we need to
False.
return no we
A
need to
value
return
false, right?
a value
Value
false, right?
false.
So it's gonna be a
That's
l bool false.
Literal, right?
Oh, literal, sorry. So e literal false, and everything else. And if you get something else, then we just call eval with environment. Uh,
oh, that's a fail, and it will not happen in in practice.
no, this is
What?
not a fail necessarily,
It
because this
is.
can be a true, right? And if it's a true, we need to go on.
Oh, okay, sure. Yeah, but then it's not a
Yeah,
underscore.
there is another case, right?
Yeah, there is another case, but I was assuming that the other one with the underscore will never happen, like non not being true will never happen, and that's why we're still gonna have to do a fail here.
Oh, okay.
Uh, fail. I don't know.
Yeah, folks, I will have dinner. I'll be back in a
Okay,
second.
this should never happen.
Okay, then we do the
I have a
run.
question though. Eval with environment.
But
What
we
this
are
guy
not.
expects? This expects an expression.
Yeah, but we are not checking for the for the empty list. Yeah.
No, we are.
No, but we need to.
Evolve with environment
Oh,
getting env, but then we need to do e operation op and this. Yeah, I guess. Um,
I think we probably will need to change the order of those functions and do another case with the empty list, or at least inside this function. Because see, you need the stop case, right? Your stop case, you have the thing being empty, I guess,
oh my
but
god.
not the same being empty as the operator there.
Yeah,
You
you're
can just put that
correct.
function as the first and do the match. No, wait. That will not work, I guess,
No, it
if
will.
Haskell works that way. Because when you call this, it will match the first case, because the first case match an operator, right?
Return.
I guess you have a complaint about like a case that doesn't happen. Let's see what Haskell tells us.
No, we are obligated to make the monoid in this case.
Wait. So why isn't that a warning on that line? Because doesn't the first case fix that?
No, it does, but we're gonna have to change. We're gonna have to move this to the bottom.
No, but then if it does, why Haskell doesn't complain about unreachable case?
No, because I'm not using Emacs, so probably it is complaining, but I don't have the.
Oh shit! Okay, I forgot about that.
Anyway, we are obligated to make the monoid in this case now, which is
We are not
interesting.
obligated. We are not obligated.
We are because we need this. This
Uh,
is doing two rows now. This is not only being the monoid for empty. This is also the stop of the recursion.
yeah, but take a look. You can do the following. You can forbid the thing to initially have less than two or less than one, and once you know you have this,
Oh
then
yeah,
you can go on
no,
this recursive function that will use the empty case.
no.
So,
Okay, that is a solution. That is a solution. But I think we are already settled on this one.
so yeah, but then you need to put them as like before the operator, right?
Yeah, I'm gonna put the operator, the first case with the empty list at the bottom. I'm just gonna change it to or here.
So let me try to see that. So if it is the end, the end is true, right? So okay. Otherwise, we have at least one, and then we evolve the thing with the either, I guess, right?
Yeah.
And if it is okay, we then can match on that.
Mhm.
And if it is false, okay, yeah, if it is false, we just return false. If it is true, we go on. And that's why we know, right? That, oh, holy, that's really nice, yes.
Yeah, but then this guy here needs to go at the bottom.
Because it only stops if it's false and doesn't matter where. And if we were able to reach the empty one,
Sorry,
then
removing
we know
your view.
that the. Hmm?
No, I removed your view of what you're reading.
No, I was just thinking.
Yeah. Okay. So operator
Should
this
never
does
happen.
not have an empty monoid.
That's a lovely and beginner friendly error.
I have to agree, but if you're using our language, you should know.
Yeah, that's a shitty argument.
If you're using our language, you're very weird.
Yeah, for that matter, people using the most weirdest language don't even need errors, right? They could just read the source code and implement themselves the error.
Uh, okay, but let's continue then. So, and that's those are the empty. Oh, but we also. Oh, that's. Man, I think we're gonna have to. We can replicate this thing. Not. We don't have to replicate it. We can just do pattern matching here already. So op plus, right? Oh man, but I don't want to do that because it's gonna be so repetitive, right? To do one by one.
I don't know what you mean, man.
Because
Can
now it
you?
means to do the four operations. We already tackled the logic
No, no,
ones.
no. The thing that you did for the or and for the and will not have the same scheme as the others. The others can be made more easily.
Yeah, that's what I
You
don't
do.
know how we're gonna do that because the four remaining ones, only two of
You
them have
will little.
monoids.
Oh, okay. You are saying for the non-monoid ones, we need to do something, right?
Yeah.
Oh, okay. So let's do the monoid ones first, right? Like just fold them, I guess.
Okay, so it's gonna be no, but that's also a problem because when
Why is
you
that a problem?
fold, the initial value is the monoid, and they are different depending on the type. If you're doing a multiplication, the folding starts with the one.
Yeah, but didn't we forbid them to be zero? So you can just check the first, right? To know its initial value.
Oh, so you're gonna do the approach that we were talking about before. Okay, I thought
Well,
we.
only if you are overloading the things that can be monoids, right?
Yeah, no, but I think you're right. So in this particular case, we're gonna do a case of the first,
By
right?
the way, we need to have a bunch of care for not to mismatch stuff between what we are doing there and the parser, man. Otherwise, it will be a disaster.
I have to agree. I have to agree. Um, okay, so we have the operands, right? Actually,
Parse of function. Such a nice concept.
we can already pattern match here. So case x of. So these are all expressions. So the first one needs to be if you are an illiteral of an L integer with the first one, then
Can you really do that before we return the... Uh, oh, okay. That's doing the binding, right? And, well, you will only care about doing the operation per se if they also see the, right?
I
Oh, I
guess
see.
so. I never tested this before. Like if you are doing a for, because I recently got use of using this for in the traverse because they're basically siblings. And I don't know if you have like an either and you have in the middle of the word you have a left, the for will stop. I will have to we would have to check that separately. I'm assuming it does because that makes sense. But that's just a guess though. Take that as it is. So if the first is an integer, if the first is an integer, what should we do, Nathan?
Oh, you need the at, right?
The at?
For
What do you mean?
the... Oh, no, we don't. Uh, just thinking of something else. So, okay, yeah, then you just do the fold, right?
Yeah, I
And we know
guess.
its initial
I
value.
think we already did the fold. No, we didn't. Okay. The
Like,
order
just
doesn't matter,
no.
so we can use fold R. Oh, and by the way, I discovered that we shouldn't be using this guy. We should be using this guy.
Yeah, lazy stuff, right?
Not because it's lazy, but because the lazy version has a problem with performance. Uh,
Haskell, such a nice PHP, man. Ah.
no, that's not the case with fold R. We don't have to use fold R this. We can use fold R this because it doesn't have the
Okay, you
performance
still have
problem.
the problem on one. That means it's a nice PHP or JS. It's a patch.
Oh no, but in this case, I agree with Breno that it has a lot of bloat. Like there's a lot of band-aids, and that's
Yeah,
actually
yeah.
what. Not I don't know any language that it's perfect, and this is the problem with Haskell, the band-aids.
Well, I don't know
Uh,
about perfect, but you know a bunch of them that doesn't have as much of this problem.
yeah, that I agree. Okay, so we're gonna do a fold R, right? I always forget the order of this crap. Fold fold R. Okay, so you pass the function, then you pass the accumulator. So you're going to have a function of some sort here. Um, then we're going to have the accumulator, which will also, oh my god, this also depends. Um,
Yeah, but that's easy, right?
okay, I have an idea. I do have an idea. It's curry.
Oh God, not even start with that, man.
I will. I will start with that.
That's so bad.
Um, I don't know. I'm gonna just make later. We can change the names. The operator function is a function that picks an operation, and it's gonna return you. It's gonna return you a function.
Can you derive our containers as functors? So,
Can't we derive? I don't know what you're talking about.
so you see the liter, right? So it has stuff inside. That stuff is a container. Wait, no, forget about it. Forget about it.
Okay, I'm back.
Oh, I know what you mean. We could.
Yeah,
Oh, we
but it's
could.
monoid that I want, right?
No, no,
I
no.
want
But no, no,
to.
no. But to do what I think you wanted to say, we could. We could implement the functor of the literals and throw exceptions for the other for like the
Yeah,
unit and the stuff, and fmap the plus.
no, but that's not what we want. What we want is to get the list of containers and transform in a like container with the list, and then we can map to do operation in it, right? So that's monoid also, right?
No, no, no. But what I was thinking of doing is to pick the function, like I don't know, an a to a here, and put the initial value here, and then you pattern match, I don't know, op plus, and then you return the plus and the zero,
Why do you use a tuple, man?
because you can curry later.
Oh, I see what you guys are wanting to do.
Well, if you have already carried
Yeah, we can do curry operator operation,
Mm-hmm.
and
operation.
yeah, and then the accumulator. Yeah, this guy is already. Um, wow, this is doing two things, right? This is the function of the fold, and this is the initial accumulator.
Yeah.
Wow, I never did that before. Okay, and then you pass the list, which is this case going to be just x with x-axis,
Yeah,
and that's it.
that's cool.
Wait. The operation there. Operation.
We're not gonna do. Oh, but wait, we're not gonna do these for the
Oh,
others, right? The
plus.
multiplication, the division.
Yeah, these ones we are just gonna throw exceptions, I guess.
Mhm.
Oh, okay, it's a tuple because it's your
Hey,
return there.
we could return the thing, but then the minus is the inconsistent behavior. We can keep the same way instead of throwing an exception.
Okay. Oh,
By
well,
the way, how? But here's a question: like, how would the exception work here?
it's because the exception, when you call an exception, it picks whatever string and returns a, but this a is like whatever.
No, no, that's not what I'm asking. Actually, like in the context of this fold,
Hmm.
like, isn't it a fold for anything? Like, we do have a case for the. Oh, okay. I think I see the issue. Like in the division, we could pick the first one, right, as the initial case. So instead of doing a fold, or instead of doing this error, what about unpacking the thing and then checking before? You see what I mean? I need to I need to stop with the checking, man. I cannot.
Check it.
Yeah, saying checking, like, because most of the time it doesn't make sense. But what I mean here is, in this case, it is a default case, right?
Yeah.
But what I mean is, in the case of a division, it doesn't really make sense to do this, right? So instead of doing div, like throwing an exception, what about we throw something like a flag? It could be a data type or something that lets us know that this, okay, so this case, you pick the first element of the list and then you just change the behavior. You see what I mean?
I see what you mean. I don't know how. Well, we're gonna have to make another function that does all of that crap.
Ah,
Oh, wait. Oh,
no,
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 then
wait. Then I guess it would be better to do a function
the
that
picks
receives
another
the
thing, right?
operator, the
Yeah.
list, and does the operation, right?
Yeah, but I was thinking about this. We need to change this.
Yeah, no, this function would be participating on the fold somehow.
Oh, yeah, they would be inside each and every one, the ones that are monoids, right?
Um,
Aside from the or in the end, I guess.
Yeah, like all the ones that we're not treating. Yeah, we
so
would still
sorting
need
this,
an
right?
exception. Wait,
Oh, I
Oh,
see what you mean. I see what
I
you
see.
mean. Yeah, so but then we can just put placeholders here
Yeah,
because we're not gonna use them.
on the division we do.
Yeah, in the division we do, and then we can return the tuple. Um,
wait, operation.
so this guy will receive X also.
Wait, English.
Wait, this would be
Minus.
What the
minus.
fuck
Why is
that?
this the only one written?
That looks so wrong. Wait.
It is wrong. I think it's very wrong, but it is a solution to what Magata said.
Let
Uh,
me see.
let's just do it before we think. Do it before we think.
Oh, the and the or should be errors, should be exceptions because we're already pattern matching and doing them
How
separately
is
here.
the or in Haskell this?
Yeah.
Okay, and where's the
So this should be false and this should be
uh?
true.
Oh, capital. Okay, and the minus is well minus, and we're gonna pick the initial.
Yeah.
Okay, and then here before doing this garbage,
No, it's already
we
done. It's already done. We
oh
already
you're
have the first
passing.
one.
Yeah, okay, yeah.
Dude,
Oh
I
no no
guess
wait,
we
this is
have
first.
a,
This is
I
first.
guess we have a really nicer way to do it, but
Oh,
Haskell
but
doesn't
wait.
support it.
Oh, but wait, Lemus. You have an initial case, but then you need XS, not operands, right?
No no no, but we have operand. Oh, excess. Okay, okay, okay. That makes no no
But
no no no. That's a
but
problem. That's a problem. You know why?
mm,
Because we don't know that information. We only know it here. Because if
wait.
we are doing a plus, we need the first one. Because our first is 0.
Oh, yes, that's true.
Crap!
Well, we can always pass. We can always pass. Oh man, let's just drop this. Screw it. Let's do initial. Yeah, let's just drop it.
Magenta totally said, screw it.
I surrendered.
Screw it.
Then,
Then we don't
if you
need to
are
make.
using
Yeah,
everywhere, you don't need that
yeah.
there.
Then we can just return this guy
Yeah. Yes.
And that's
and
literally a mapping from the.
Yes.
and then it's this, and we don't need the curry anymore. And then we can just forget about it.
Then you have a
Uh,
problem.
mm,
What is the problem, Nata?
Yeah, the problem is because since you were always passing, now you still need to pass on the outside, but if you pass on the
yeah.
outside without matching the different ones, they will be the initial for all of them.
That would be the initial for all of them.
I don't know if I got it
Oh,
now.
no, no, okay, sorry. You are actually like matching the elite code. No, wait. you are not matching the operator. And well, I don't know what you wrote operation there, but I guess it's the operator, right?
No,
And
in here.
since you're not matching the operator, you don't have a way to know which initial one you are passing, right? You have to pass at least.
Oh,
Because if you don't, you pass the same one to everyone.
I still don't get the problem. I'm sorry.
Yeah, so you are doing a fold, right? And it's a fold on what could be different operations, right? They can have different kind of operators. So how do you know which initial value to pass if you are not matching the operator?
Yeah, we don't know that. That's true. Well, I guess we're gonna have to make yeah, we don't have, well, yeah, I don't think we have a choice.
I mean, you
We're
see,
gonna have to make the
Like the
folding function here.
solution would be a or in the sense of I match the operators. If the operators are the ones that are, for example, monoid ones, then I can treat them like equally and just doing the function of okay, depending on what is this, this gives you the initial one and the function as you were doing. And then the others we could treat differently. But you can't do that in Haskell, right? Do a OR and treat the cases in the same way.
No, I don't think so.
Holy shit.
Yeah, I don't think we have a choice. We need to make the folding function ourselves, and then we need to check at each iteration if the member coming from the container, if that is the type that we expect with pattern matching, and if it's not, we just throw an exception. I don't think we have a choice in this case, which is very unfortunate, but that's how it is. Did you see what I said, Nathan?
what about we use this special syntax to handle cases, and then you can define your own monoids?
Wait, what?
No, but that doesn't fix
I'm
the
thinking,
problem.
I'm thinking B. No, I'm thinking of another issue.
Oh, okay. So Nathan, what I am suggesting, we're gonna have to receive here an expression, and here an expression, and the return will be an expression, and this will be the folding function, right? So we pick this. If this is this needs to be an illiteral, right? And this needs to be uh, an L integer, for instance, and then I don't know.
Oh, that you solve the evaluation requirements of the NDR, right?
That would.
Because yeah, then since you are receiving an expression and not a value, you could evaluate the and the or differently, right?
Oh yeah, we could combine all of them instead of doing this other
Yeah,
stuff.
but what about the monoid? There you have anything regarding the initial value. And if all of them will be in a fold, how will that work?
No, it's gonna work the same because
Well,
this
minus
guy
will
will
really
still
be a
exist.
or? No, no, sure. But what about the ones that are not monoids? Will they still be a for with the initial value and such? If so, then we have the right answer with that function. If don't, then we
Okay,
have a problem.
let me stop daydreaming with the language. So, what is the issue?
The issue is we want. Mageta Nathan said, "Oh, how do you know that inside these operands we have the same type? We have all integers or all
No,
rationals."
that's not what I said. That's not what I said.
No, if that's not what you said, I understood that, and the solution that I'm proposing is to solve that.
Yeah, because that's not a problem since the type checker will do that, right?
Oh, that's actually true. The type checker will check that for us.
Type checker, our friend, man.
Yeah, so then my question
What is Nathan's
becomes.
problem?
I have a bunch of problems.
Yeah, go one
But
by one. Go
the
one by one.
problem I have with this code,
No,
and
no,
not me,
that
is
okay. I
but
mean, what is the blocking point here?
so
Yeah.
okay, we have a folder,
Oh,
right? And that's the thing. The folder are dealing with different operators, and different operators require different initial values.
yes.
But the initial value is not depending on matching the operator. Then we have
Yes.
a problem,
Wait,
right?
the initial value is not depending on the matching operator.
Yeah, that's correct. We just decided it's gonna be always the first, all the time.
So that doesn't work at all,
Why?
right?
Why not?
Yeah, that works.
Wow, because different operations have different initial values, and we are passing the same for
No, but
all of
that
them.
no,
Yeah,
but
but
that's
it.
what Mageta said before about dropping. Like when he said, "Oh, let's just drop this thing." That's what he meant.
Oh, I think okay. Like you're thinking we're still doing the plus like with this.
No, I'm seeing one thing, the line 93, and we have a folder.
Yes. What is the issue?
Then we have initial value, that is the...
Yes, the initial value is
Oh,
the first thing from the list.
oh, okay, so you have at least one, okay. All the cases.
But dude, here's how is this fold working? Because XS is still this literal garbage, right?
No,
Don't we need
that's
to unpack these
exactly. No,
things?
exactly. Now that's what I'm thinking. Like we need to unpack everything
Yeah,
throughout the
to
fold.
see, yeah, like matching again, right?
Yeah, matching again and again and again.
Oh, that sucks.
What
Let
is
me
that
think.
operation, Lemos? The operation where you have a list
Should
of
be
containers and you want to return something like the container, but not the container with a list because it's not generic, but the container with some function applied to that list that will result in only one element. Like, let me write in the chat.
I
Oh
think you're
man,
talking
that's
about
that's
applicative or
really
monad.
bad.
Yeah, I guess that's monoid, isn't it?
Can we do like some sort of or here? Like,
Man, wait. We can do what Nathan said. We can implement the append.
can't we do this? I'm just inventing syntax probably. But something like this.
No, that's not a thing on Haskell. That is disjunctive pattern matching, which is what Nathan has in OCaml.
So take a
Uh,
look in the chat.
Isn't.
take a look here on chat. Yeah, that is. You can do that with.
We do
Wait.
that with R and end, right? Or
No.
something like
I
it.
see the
Isn't it?
thing.
Uh,
My only problem is that it is not exactly that, right? It is
It's not exactly that.
no, it is like this, right?
You mean the function that we have
I'm
in...
typing. Hang on. Like it is what I mean is it is wrapped in another garbage. Like so we need to map
No,
to
no, but
some
they are
sort of
all liters, right?
no yeah, they're all
Oh, no,
literal.
okay, sorry. It's because I... Yeah, sorry.
Yeah, I'm
Just
just
change the literal by L integer, for example. That's what I meant, right?
no
I
yeah, I know,
think that
but
what you
this
want is a sequence combined with an F map, Nathan.
sequence, what does sequence does?
Sequence speaks. If you can look at my screen.
Isn't
Yeah,
that thing
okay.
that does the list of results, the result
Oh,
of a list?
Yeah.
But we
oh,
don't want
it
like
just
that
speaks.
because we can't have a list inside our container. So we need to do the F before,
No, we already have a
otherwise...
list
Can you
in
test?
our container is a list.
Can you test?
No, no. Our container cannot have a list.
What?
Yeah, because the result
What is
can
our
have
container?
anything inside. Our container is the L integer, for example.
Yes.
It cannot have a list inside. That's an important detail.
No,
Because
but
when we are doing this
But
with results, then you can have a list of results to the result of a list, but we can't do that with
oh
the
no
L
no no
integer.
no. Now I
We
understand
need
what
to
you're
do a
talking about.
F first,
No, I understand what you're talking
right?
about, but I thought this was just an example. So you want this operation that you just typed on chat. So literal list of literal one, literal two.
Yeah, but change literal there by like L integer, right? Because
Yeah,
that's how.
yeah. So yeah, so
It's actually E literal with a L integer inside. That's what I was talking about.
Oh,
That is the
yeah,
problem.
but
It's like two things. I'm just
yeah, but
raising the
that's not a
numbers.
problem. It's just that I written wrong. Let me just give me a second for me to update.
Oh, it is a problem, right? How are you
No,
gonna?
no, not really, because we don't care about the literal.
How
yeah,
do
we
you
don't
not
care
care about it? I know
because you
we
can
don't.
pattern. We can.
They are all literals, therefore you can just like
Okay, you
extract
can just
whatever is
remove.
inside.
But shouldn't all of? But aren't all of them the same as well?
I'm not
Oh, the
getting it.
second one you don't know which one it is,
No, no,
right?
no. We know because this is already assuming type checking, Maggot.
No, no, no. What I mean is like there on the illiteral you can just get rid of it, but on the L integer you don't. You don't know if
Oh
it's
yeah,
a
that's true.
rational
Yeah, we don't
list
know.
or
Yeah, we don't know.
something.
That
No,
we
no,
don't know.
wait. Can
Can you
you
try the
explain me?
sequence?
I didn't got it.
Okay, so what I was saying is we have a way, an easy way to unpack the illiteral because we already know it's the same, right? It
Okay.
is the same for everything. But we don't have a easy case at least to unpack everything from the L integer
Oh,
part.
as we would do with Alibu also, right?
Yeah, because there is
That's the part
Alibu,
that
there
comes
is
with
a
type
rational
classes,
and
right?
everything.
And monoid stuff.
Can you run that sequence function on the REPL, Lemus?
Yes.
Let's see what it does.
Um, it does. Oh man, I always have an example for this. So let me try.
Do a adjust garbage.
Uh,
But we are also just transferring where our code will be, right? Because we will need a bunch of instances implementing all of those.
is this? Oh man, I don't remember anymore how to use sequence. Do you remember, Nathan?
You have types there, man. What is
No,
the
no, it
type
is
of
this.
sequence?
Yeah.
Aha! It is
That's
this.
really nice.
Okay, so do you
So,
see?
mhm.
Yeah, but doesn't work for us.
Can you do with like two things? What does it do? I'm curious now.
What do you mean
You
by
need
two
them.
things?
Like the sum is not a good type. Think of either. Make an either list, like right and left.
Oh no, no, you mean removing the just input nothing in the middle.
No, no, no. Yeah, but nothing is not
Like,
good because you don't have anything inside, right? But either because you have right and left.
but
Okay.
just is the maybe, right? So,
I know, man.
but he will just consider the left as the nothing, I guess.
Okay, that's fine. I think. Let's see. So it just picks left one.
Yeah, but well,
I'm
let's put
surprised it
other
didn't.
numbers. No, it has short circuiting. The sequence has short circuiting.
Mm-hmm.
So in the case of the left, it short circuits to the first left that it encounters from left to right. And
So
in the
that's
first of the
actually good,
maybe,
right?
sorry?
So that's actually good.
Yeah, no, it is pretty useful. It's only,
No, no, dude. Like here's what I mean. Like we expect always that the all the operands they have the same L integer, L bool, L rational, right?
yeah.
So we can unpack twice. We can unpack the literal garbage from everything, and then we pick the list again and unpack again. If it
Wait,
doesn't, and then if it like just spit this, then I mean short circuited. But on the second element, like left two.
No, 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 but I don't think that's the case because to use sequence, you need to have the thing inside needs to be a monad, which is not our case.
Oh, it
Uh,
is.
no, it's not, right?
Oh, it is. Try with the data type. It's the same thing.
Okay, try with the data type.
Oh, yeah. The stack REPL.
Oh, it's broken.
Oh. Oh, but can you run the thing or do you need to evolve everything?
Wait.
I'll remove that garbage. Yeah.
No, it's still
What?
failing with types.hs. Types.hs. It's complaining about this guy. Oh, it's because it is deriving this. Did I save it? Yeah. Okay.
Not
Line
find the module.
115 types.hs. Yeah, it is complaining about this, but what? I am confused. Operator, I already removed the show. What are you complaining, my guy? Source, OP binding, pattern barriers and instance declaration. What? I am confused at the moment. How is this complaining about something that we already fixed? This doesn't make sense.
Can you just remove the show?
Yeah,
Yeah, just put
why not?
show and remove the garbage. Comment it. Let's see.
Doesn't make sense, but okay.
Okay, now it's some other stuff.
Types.hs 9136.
36.
There's a
Oh,
line missing here. Wait, what is this?
I don't know.
What?
Open git blame. Open git blame right now. Generic arbitrary.
Level
No,
5.
you need to. You need to. Oh, you need to have this line here. Instead of let's sort, you're gonna have operator. Okay.
No.
Evaluate your prelude on this guy. Line 28.
28. Map from list. Show R print.
I am confused. Because this should be. This can be this.
What the heck, man?
Yeah, our print is here. Oh no, it's having a problem pattern matching stuff. Okay, I see. So it is saying
Okay,
that couldn't match
results
expected
P.
type value to this
What
with
is.
value. Expected type this, but got something else. Oh, I know why. It is because this needs to be a vnative function.
Oh, makes sense. Remove the thing.
Cool.
Oh, dude, what the heck? Dude, I just want to test, man,
let's
dude.
just remove all the things related to the e operation then. That's definitely gonna work.
That's why some people hate type checking.
Yeah, I understand.
And
I understand their lack of will.
variable not in scope. Okay, so let's go to the bad fold again. Who cares? Okay.
Okay, finally. Now
So
just try the sequence on the list.
what do we want to do? We want to make a list of
Of
elitero,
expressions. Yeah, it could be illitero and put the, yeah. And
L
then like
integer
a
1,
integer, yes.
elitero, L integer 2,
Mhm.
and it's good for now. Okay, and let's
Okay,
put sequence
sequence
D.
that.
Uh,
Error.
it is
Expression is
saying what I
no.
said. Expression is not a monad,
Yeah.
which means that
My
we.
question is, can we make the function necessary to run that?
I don't think we should.
That would mean, Mageta, to transform, not to transform, to implement this
Mhm.
guy to a functor, applicative, and a monad.
Yeah, I don't think it would be hard.
But then we would just be transferring
No,
their code,
no,
man.
because here's the thing: we just need the return on that case. I think you know the
Uh,
return from something like this.
uh, Man, I don't think we. Well, I need to think
That
about this
would
a
be
little
so
bit
easy,
more.
man. That would be so easy,
No,
man.
it wouldn't because we would have to implement the functor, the applicative,
No, no, no,
and the
no.
monad
I
to
know. I'm
all of
saying
those.
if we had, if it worked like out of the box, it would be so easy.
Oh, yeah. Actually, there is a thing about derive functor.
What was
Haskell.
that function in Okamo that you can convert to any other type? Was magic?
Yeah, magic.
Oh, something like that. We need magic.
Man, I think I took another decision, folks. I will not use our parser nor our evaluator. I will write in the ESD and I will only type check it. Like that's the way I use the language.
And what are you afraid of, Nathan?
What do you think, sir?
There is a way though. There is a way of deriving things automatically. Yeah, like this. You see?
Uh huh.
So apparently is a idiomatic stuff, and then there is a way of deriving stuff. But like I said,
Ooh.
I don't think we should. Uh,
Yeah, I think that's true. True. Dude, it's because okay, like I don't know how to do that in Haskell, but I think in F sharp this would be so easy, man. With the extension on the man, I forgot the name. The computation
What we
expression.
need is the OR, man. Like we don't need anything fancy. The OR would solve a lot of stuff there.
well, to be
And
honest,
I guess we should accept some code duplication and then we see if we have a not horrible way to do it.
yeah, but to be honest, like I can kind of see. Well, not to all of them because some of them doesn't make sense. For instance, the application. What it would be to fmap the application. Like I don't have any intuition about that. But to the operations, for instance, oh, I
Yeah.
want to fmap the expressions. That kind of like sort of makes sense. The literal we don't have a choice. The variable we don't have a
Sort
choice.
of.
But the application where you have two expressions in
And
both.
just a shady question, okay? Don't get me wrong. Do we have an arbitrarily sized either? It's
Uh,
not an either, it's a choice, right? But do you have an arbitrarily sized choice?
I never heard of that.
Like choice one. I mean, let me type where you
Yeah,
are.
no, I know what you're talking about. I never seen that. But
Hmm.
anyway, I think we should go with Nathan's approach of like accepting code duplication at first, and then going up from there. Because if you think, because doing the fancy
I
stuff,
just thought of a solution. You know how I would solve this, Nathan? Guess what?
Meta programming.
Reflection. But I don't know how
Well,
to do
okay,
that
the
in
worst
Haskell.
kind of
So
meta programming.
that would solve the problem. That would
Good
solve
luck
all
with
the
that.
problems. You would create more. You would create more, but you solve this. Anyway,
Okay, that's fair.
it
so
would
let's
create
go.
more problems, but it would
Oh,
work.
that's accurate, right?
It would work for
Okay,
sure.
let's just go back.
Uh, okay. Um, then we need to do what oh man, it's gonna be so hellish because then we just transform this to the folding function,
Hmm.
and then oh, the member that we are receiving is an L integer, and it has I don't know an element inside, and then the accumulator also needs to be an L literal, L integer, ACC, and then you just say, okay, can you please wrap this up into this? But I want you to pick the element and do a plus with the accumulator. Yay, like that. But there's a problem though, because every single time that we have a new operation, we're gonna have to do maybe
Yeah.
3 pattern matches because we need to pattern match when this is like anything else. We need to throw an
Hmm.
error.
Oh, by the way, I think we should add other types already to the AST,
Other types, what do you mean?
like string
That's it.
list. You know, because right now we cannot print strings because there are no
Mageta.
strings.
We have functions, man.
Okay, and
So why do we need strings?
oh no, man. Like you're not saying the thing we are doing, the kung
Mageta,
fu to print stuff, man.
let me reason here. We have
Okay.
functions, therefore we have names,
Yes.
therefore we can encode characters with ASCII,
Oh
then we
no,
have
no, please,
strings.
no, screw yourself.
Oh
Oh,
no,
so
forget about
remove the
that. We don't have
integers.
lists. We
So
don't have
remove,
lists yet.
yeah. So remove the integers as well. They're useless. Just use
Yeah,
the piano numbers.
we can code them with lambdas.
Yeah, who cares, right?
Piano numbers.
Yeah. No, thank you.
Oh yeah, we have naturals, and with that we can code numbers and rationals, right?
Yeah, but I think those are to feel comfortable. I think let me just add that already. It shouldn't be hard to. Yeah, here.
Yeah, but from this point of view, Mageta is right. Like having the entire arsenal of functor, applicative, and monad would make our lives a lot easier.
That are
Only
most
if
of our
they really
code.
are.
Most of our code, I think, would be easier.
Like if we are doing lawless type classes, then that will become worse in the future.
Lawless,
Wait, isn't
Wild
that how
West
I said
type
something
classes.
without the law?
Uh, that's a good question, Mageta. What you gonna put there?
Wait, don't where?
Yeah, we have lists,
Oh,
right?
you're looking at what I'm saying.
Yeah, I'm looking.
Yeah, I was thinking of just doing this, but then it needs to be a list of the same
Expression.
thing, right?
No,
But
no, no, but that's not a problem. What I'm thinking is, what if you
oh
want to have a
yes, it
list of
needs to be
functions?
expression. Yeah, it needs to be expression.
Okay, now we have for the first time multiply recursive types.
Yeah.
So they depend on each other. That's cool.
At
That's
least
cool.
we are not using it necessarily. Like we need
Anything.
that.
Oh, tuples, man. Please, let's add
Ah.
tuples. Oh, but dude, the types for tuples, we need to make a type specifically for them. Ooh, this would be annoying. Okay, let's
Yeah,
just start.
maybe you should even make hey man. Yeah, that's really important. I guess we should comment out tuple and list for now because Lemos and I was trying to review some of the type checking stuff, and there's already too complex for us to infer like what is right, what is wrong. Adding things like string, bool, rational doesn't matter. But maybe lists, tuples, and whatever, like records and whatnot, maybe
Type.
that will make even harder.
Yeah, so the
Type.
point is, Mageta, we want to
Hmm.
have Omega ready and before adding extensions because we noticed last time that adding extensions at the same time as completing Omega made the thing really more complicated.
Yeah, but like, dude, list. It is not a complex type. It is the same. And tuples. Tuples maybe depending on how interface function. Maybe actually not. I think like those two types, they're also atomic, right? In the sense of
Do you
it's not the
know why
the
they are
same thing as this.
complex? Because
Why?
taking a look on the expression, they don't look that way. But in the types, they are a type that contain another type. That has a bunch of consequences
Yes.
because we have to unwrap types, and
Mhm.
on those types that have types, we need to recurse inside them. We
Yeah,
need
but
to
he
check if
already
they don't
described
have.
the algorithm, right? That's not something.
Yeah, now try to do that without reasoning about the whole system at once. Like,
Yeah, I agree we should have tuples though. So let's put expression, but I agree with Nathan about at least
no,
for today
tuple is
comment.
also a list of expressions.
Yeah, it can be any size tuple, right?
Oh, we're gonna have fancy.
It's
Fancy
not
tuples.
fancy, dude.
Yeah, it is
It's a
fancy
tuple,
because
it's
Yeah, it
not a
no,
is.
pair.
It is.
no, it is fancy because I don't know. I don't see a point of having a tuple with 24 positions. Why don't we have a list then?
Dude. Oh, Haskell. So Haskell does not only have pairs; it has tuples, right?
Yeah, it has a multiple amount
So
of.
you have three approaches. Either you only use pairs, and then we can nest them. That's nasty.
Yeah.
Or you could do something very weird. That is, you have pairs, triples, and whatever you want. They are all hard coded in the ST. Or you have arbitrary size. What makes more sense?
Why don't we do like Python tuples that are
Oh,
just
we
lists?
could. That they have zero, right? But in
Yes.
our case, they would have at least one.
Nah, I don't think that's a good idea.
Anyway, the point is, Magita, let's finish our Omega, and then later we add extensions. Because do you remember this? Do you remember this thing?
Let me see. Uh, Yes.
This caused a gigantic discussion last time. After you
Oh
left,
yes, yeah,
I don't remember anymore when. But I was
yeah.
discussing with Nathan because Nathan brought
I
some
remember you
interesting points
mentioning.
about it. And I said, "Oh man, you're right. We thought this would be a simple addition, but actually, it's actually a little bit more complicated than we initially thought." So I think that we should calm down a little bit.
TLDR, we have some kind of type conversion on our system
Yeah, because of the reduction, right?
because of the equality and the type annotation.
Uh huh.
Like, it's quite a thing.
Yeah, so let's just finish the evaluator. At least go to the right direction with it. So I think, Nathan, we're gonna have
We
to do
have
this
the
a lot of
Let's
times, right?
working already. By the way,
Sorry.
do we have the Let's working? Because I saw this comment here. What about kind checking this?
Yeah, because when we were doing the last time around with Nathan, we noticed that maybe something about type checking or kind checking lets, but the lets are already working. I
Yeah,
don't
that's
remember.
fine. I don't remember this. Dude, we need to do a change log of stuff. Like, yeah, man. Like on the end,
That would be smart.
we can even write a book later on, like programming silverware. You know the money series. Let me look at what would be the Oh Really books
Yeah, I know.
where there's an what would be the animal? It would just a spoon, right?
No, it could
Mm.
be. It could be the entire set: a knife, a spoon, and a spatula.
I mean, dude, I will look for a picture right now.
Anyway, Nathan, I think this is the kind of like the body of the folding function. Do you agree?
Wait.
It's gonna be very hellish. It's gonna be the biggest function in here, I guess.
What? What did you ask?
Yeah, because we don't have the sequence function, etc. We need to do the fold by hand. Um, we
The first question is, can we do the fold on all of them?
yes, using this abstraction, I think yes. If we decide to go this route.
Okay. And then
The
what you
second,
are doing for that to be possible is to like disconstruct the thing there from what we need. Then the
yeah.
question is, does the compiler let you do that?
Oh man, but this would be so much easier if we have applicative. Because you see what would it be? Would be literally plus fmap and then the element, the new element of the fold, and then applicative the accumulator, and then done. Ah, but okay. Uh, because look at this, we need to unwrap and then wrap it again.
Yeah, but then you also need functor, right?
No, but to make applicative you need functor in Haskell.
Oh yeah.
But the problem is that this makes a lot of sense with the e-literal. We would have to implement to all the other ones.
Yeah.
But anyway,
There is a solution to that, but we
yeah,
know it's also
we can
hellish.
placeholder error.
Not placeholder error. We could transform the. Actually, we don't need to do it for all of them. Go to the EST. We already have the solution in place.
Really?
Illiteral, it's literal. We only need for the literal, right?
No, we don't. No, well, we if we
Only literal needs to be a applicative, right?
yeah, but then we
And
would
for
have to pattern match. We would have to pattern match to unwrap the e-literal,
yeah,
which sucks because then we're still gonna have to pattern match.
yeah, that already sucks.
It sucks. Forget, are you still looking for a image of a spoon?
Actually, I'm making the book cover right now.
Holy, the guy's dreaming.
Yes, man, I'm dreaming.
Anyway, Nathan, look at this code. Do you see any other alternative to this? Hell, it's gonna be
Man, I
really
don't
bad.
think this is alternative. Like the compiler will complain.
What? What are you talking
Like,
about?
man, we are matching stuff with the literal and with not the rest. So
Oh, you mean by exhausted?
sure.
No, but at the end we're gonna have a case that is like a funnel. If nothing matches, it's gonna funnel out to that.
Unfair, right? Okay, so yeah, if you can describe all of them in folds, like the monoid and non-monoid ones, then that's the good solution already. That is already discarding a bunch of code duplication.
No, wait. You said something that I was not necessarily planning to do right now, which is to accommodate the monoid and the non-monoid ones at the same fold.
Yeah, you don't need that, but you can do the following. You accommodate all
No,
the
that's no,
monoid
but that's
one
possible.
there.
No, but that's possible.
No, it is possible. I'm not sure if that's the design decision that we want, right? Because like we don't know yet, at least I don't, if we can describe the non-monoid ones with the fold. If we can, then we only do that function and we are finished. Otherwise, that function will only handle the monadic ones, but then we need some other instances of involving the environment, right? Matching the non-monoid ones before that.
No, no, no. Let me explain what was the initial plan. The initial plan was to separate the evaluating environment of the list with only one, empty list, and the short circuiting ones, which is the end of the OR, and everything else we would implement in here. That would mix monoidal ones with non-monoidal ones. Because this can be an add, right? And this can be a division. One of them is a
Okay.
monoidal one, and another one is not.
So my question is, can you do the fold one with the non-monoid one?
Yes. This is already what is happening here, by the way.
Yeah, then we can just finish this function.
No, but that's an issue. There's an issue because the monoidal ones, we are ignoring their monoids, right? If the operator is a plus, for instance, where is the zero of the initial case? It's not. I'm just using the first of the list. Always. You see? Nathan?
Yeah, I'm thinking.
Okay.
I don't think that's a problem, isn't it?
Well, I wouldn't say it's a
Uh,
problem. I'm just saying it's something to take into consideration.
oh yeah, that's why I'm thinking about it. And if we think about it and it's not a problem, then the consideration was it's not a problem. Ah, because the neutral applied to one will be itself.
Having so many
Wait.
ideas.
Can you repeat the last part?
Yeah. So the neutral applied to one, it's itself, right? The
Yeah.
one itself.
Yeah.
So then you use that as a accumulator for the others. Then it's the same thing, I guess, as using the neutral.
No, it is, man. I'm not saying like the result would be different. It would not. The result will always be the same. We are just kind of
Okay.
dropping the monoidal approach of, oh, the plus
You
starts
are
its
saying of
fold.
accepting zero, right? Zero arguments.
Accepting zero
That's the
argument.
only difference. We will not be able to accept zero arguments this way,
No,
right?
I agree also that as a consequence of this approach, we are dropping the support for no arguments for the plus and the multiplication. But my point is actually a little bit different in that. My point is that we discussed earlier about, oh, because plus and multiplication they have monoids in Lisp, like natural monoids, let's say, um, then we can implement those as well. But we are totally dropping this strategy by starting the fold with the first element.
We are not, because the result is the same,
No, it doesn't matter if
except
the
for
result is the same. You're not following the principle.
the principle.
Yeah, because the
That sounds
principle.
like bullshit.
No, that
Because
isn't.
the user will see the same, man.
No, but that doesn't matter. If the user sees the same, that doesn't matter at all for implementation of a language. If the user
Man,
no, we can make the same language in Erlang and in Haskell, and the result can be the same for the user. That doesn't matter.
yeah, well, okay, you are saying regarding the idea of being a monoid.
Yeah,
For the user, is that a monoid?
regarding the idea of having, I'm gonna again double quotes, natural monoid of 0 and 1
I
for,
don't know what you mean by natural there.
yeah, the natural, yeah, that's why I said double quotes, is to have this as a thing, right? That's something valid. I want to say, because only in Lisp I know it makes sense. This is gonna be equal to 0. Because in every other language you would have to implement yourself your monoid.
By the way, I don't think that's even a monoid thing, right? Because monoid doesn't establish that operation of returning the neutral, right? It only says it has a neutral and
No,
an operation.
it established actually.
It established that
Yeah,
if you want, for some reason, do an operation with nothing, you will return the neutral.
yeah.
I don't think so.
No. The way that you said the second time is different than what you said the first time. So
What I mean
what
is, it
what
established a neutral element and a binary operation, right? And some characteristics about it, I guess.
Yeah, that's the monoid one.
So it has nothing to do with, oh, I want to do operation with nothing, therefore you return the neutral. That's a Lisp thing.
Oh no. That what you said is a Lisp thing. That's not a rule of the monoid. The monoid just established that you need to have an empty element and a combination function.
Okay.
Actually, that's actually not even technically true as far as I can tell, because the reason that monoid requires the combination function is because a monoid needs to be a semigroup. And a semigroup requires a combination function. The difference between a monoid and a semigroup is
It
that
doesn't have the neutral, right?
exactly.
Is that it?
Yeah. The semigroup doesn't require an empty element. But every single monoid needs to be a semigroup. So the monoid has 2 requirements while the semigroup has only 1. But
Oh,
anyway,
yeah. What I mean is, for the user has a monoid.
yeah,
He just
exactly.
he
Not
just can't do the
not that
Lisp.
that is a good argument, because the user can have the same result with any language that we need to implement. We're choosing Haskell because of other reasons. So uh, anyway, I think I already made my point here. So we're gonna not make the first element for plus being 0 and the first element of multiplication being 1, because it's always gonna be the first one of the list, which is fine. So error in fold of uh,
Oh,
this.
Marqueta, how does the division works? Because Lisp gets the first and the
It is.
subsequent.
Oh,
Uh,
the
no,
division.
no,
Yeah, it
wait,
gets the
no, wait,
first and it goes dividing.
no, sorry. What I want to meant was the following.
Yeah.
With the minus, you get the first, and all of the others you just subtract from the first, right?
Mm-hmm.
What about division? How does it work?
Same thing.
The same thing. You get the
Yeah.
first one, and you
And you go dividing.
wait. Can you
If
write
it,
that for me? Because like,
yeah, if it is 2, it will be a fraction, I think. Like, let
but
me.
I mean the division, like the accumulator is in which side? Like, can you write the example for me of the steps?
Yes. Like, 1,
Because
1.
depending on the order, that's a problem. Depending on the order, that's a problem for us.
If it is.
But that's not a good example.
Yeah, that's not a good one. Hang on. 4. This is enough.
Like slash. Oh, okay. Oh, okay. So it gets the thing and
Yeah,
divides
I
by the
think
next one.
actually
What if I
that's not a
have
good
another
one.
two?
Yeah, if you have another 2, then
Like
that would
it's
be.
good enough to know. Oh, okay. Oh, let me see. This. Oh, then it's the same order as the minus, right?
Yes, it doesn't change.
Yeah, you get the accumulator on the left side, and on the right side, the next one. Yeah, nice, nice, nice.
Okay. So, oh man, oh man, I'm kind of very I kind of want to make the function replicative now, because look at this crap.
Sure. You want to dream, Lemus. You want to dream.
Look at this crap, Nathan. Tell me that this is not ugly as fuck.
I'm looking for Clutterware. Clutterware? Is that it in English?
I don't know what is that, but okay.
Just silverware, whatever. It's just that I didn't want to use the same word. But anyway, I'm looking at spoons and such.
Man, you should look for a set of a spatula, spoon, and a knife.
Yes, I'm looking for that. I found one perfect, but there was a watermark, so I didn't want to use it.
We can buy it. If you're willing to make a book, I can buy the picture for you.
To make a cover, dude. Let's do it.
The experience of three not busy enough nerds.
Yes, that's a prime example of not being busy.
We implemented the same language kind of twice. Discover that types are useful, and here's
Oh,
why.
it's a total different language already, man. There's no way.
Yeah. That's gonna be the title of the session. Let's make a book about this.
No, no, dude. You're gonna put this at the thumbnail. Just a second.
I don't
Maybe
know if
not
I'm
at the
gonna change the
thumbnail, but
thumbnail because I really like the
yeah,
thumbnail.
it's gonna be different. Yeah, but anyway, you're gonna see this at the very least.
Oh, and Ju knows how to draw very well. You can ask him.
Oh, so we have our guy to
Yeah,
make the book cover.
if you search his profile on Instagram, you're gonna see some of the drawings. It's pretty good. Um,
Find a fork, man. That sucks.
that's no, we don't have a fork, but well, who needs a fork anyway? We have a knife, a spoon, and a spatula. That's all you need.
What about like kitchen utensils? Oh, this is perfect. Oh, but there's a watermark. Yeah,
Yeah,
but
no,
I,
good
I
pictures then.
already envisioned. I already envisioned what we can ask for Edu.
Ah, people dream about having gold and cars. What Magetta wants is totally.
A book cover with a knife and a spoon.
Yeah, that's what you want.
I'm literally looking for like 15 minutes at a perfect
Back.
picture. Oh man, this book looks so good. No, serious man. Like this looks
Wait,
so
you're
good.
taking a look at what?
He's still looking at the book cover.
And I'm making the book cover.
Ooh.
He wants to scream at the world, saying that having types is useful. Like not.
Oh, in a Lisp, right? That's the most wild thing you can do.
Well, I think this is it. Uh, Manhattan. So let's cross our fingers that this is okay. So what we want to do? We want to just say return
Lemos.
fold R.
I just want to say two things, man.
Uh.
The first one is that I trust you, and the second one is that I'm not worried, not the slightest, with like us having errors with this function. Not because I trust you, but because I will not use it.
Oh, Nata is true. Nata is just bitter, man.
Yeah, Nathan is
Like
kind of boring today, but that's fine.
What do you mean?
you
Yeah,
should you should boldly, dude. People use JavaScript daily.
that's a fact right there.
Yes, that's a fact.
Yeah, but they have like more investment than the people investing in curing cancer, man. So I guess you can rely on that. Like that the
I
language will work, not that the people will make right program with it, right?
I think
It's
our
not
language
that
is
Java's
already. I think our language is already 1 degree higher in consistency than most.
no,
Not
yeah.
most, but some. Certainly some. Certainly some.
But that's the trick, Magenta. That's the
Most is an
trick.
overstatement.
You have two things, right? One is, does your language have bugs? And the other is, given that suppose your language doesn't have bugs, is it easy to write bugs in it? In the second regard, ours is already like much better than JavaScript. But in the first one, it's harder to tell. Right? Well, it's not harder to tell. Like we know that it's not better than JavaScript in that regard, in the sense of being rightly implemented, right?
Yeah.
dude, like they have those for years.
It cannot be so hard, man. I just want man. Oh, this is fine.
Running
This
scope.
is actually pretty good. This is actually pretty good.
Oh, it's operator. I'm done. Oh, and that also applies to this guy. Okay, this is some progress. Couldn't match. Oh, it's because this isn't a fail. This is an error. Okay. Ooh, that's interesting. We have a problem, folks.
And what is that?
So, do you remember that we are picking the list of expressions of the operator and then evaluating that? This is not a
Yeah.
list of expressions anymore. This is a list of values.
Oh yes, that's true.
Yeah, but we can just change to value. Like the only reason for you to have expression there is if you want to personalize the evaluation for the end.
Which you are not doing.
Yeah, we are not.
No, but then I am very confused.
Hmm?
Then I'm very confused because if these are a bunch of values, our fold should be value to value to value, right?
Yeah.
Yeah, but then the question becomes, how do we fold? Where is it? Oh, it's not here. It's here. How do we fold this scrap?
Like V liter, right?
It needs to be a V liter. If it's not, we're
It's
done.
literally the same thing. You just change the E to V, right?
No, it's not the same thing at all.
How isn't that the same?
Because because oh no, you're using the same literal inside. No, you're correct. Sorry for that. So this is a value, and then we're gonna do all those
The amount
equations.
of repetition that they.
Yeah, this is because we don't have applicative and fmap. That's why.
At least you have an efficient way to do that.
Wait, what again?
At least he has an efficient way to
Oh
replace.
yeah, he's using the max of Haskell.
Evaluator 76. um,
This is perfect. That's it,
Okay,
folks.
though, we want to see that cover, man.
I just I just need to save this. Let me open GIMP
This,
and then I'll paste the PNG. And that's it, Nata. We have the cover. I'll ask for Edu for another one
where are
and
you
see.
sending that?
I'll send here just a second. I'm still editing
You
just to
know
do.
the style of I don't know or relay book
Yes,
stuff, right? Okay.
yes. That's exactly the vision that I want to capture here, Manus.
Okay, so couldn't match expected type. So probably I am doing something wrong like this, and this also needs to be applied to this. But now that I think about it, actually it kind of makes sense to put a lot of functionality to the literals. Like we
You
should, we
want
could
to what?
yeah, we could implement the semi-group. We could implement the F map, the applicative. Those would make sense actually.
Oh, I see what you mean. Yes, that makes sense. I was thinking of that for the monoids, but yeah, we can extend on the rest. That would be cool.
71. What are you complaining now? Oh, these guys are still V E. You should be V. And you also. Oh, but oh wait. Okay, so this is wrong then. This is evolve with environment. Env x, because these needs to return a value and we have expressions. Okay. And I don't know how to write. Cool. Okay. Two more. We're getting close, Nathan.
Close to what?
Oh! Look at that! Just look at
Oh,
that!
okay, compiling.
Really not working, just compiling.
It is combined. Okay, but this piece of code.
You're just
This...
demoralizing the thing, man.
Lenus, it could be much worse, man.
I
Let's
know.
get a better
Everything could be
image.
worse. We could die right now. Everything could be worse.
No, no, our code could be worse.
But I'm so disappointed because now I am kind of like, man, applicative. That's exactly why it is a thing.
This. Oh, it's
Well, I'm
perfect.
gonna
I'll
think
just
about
add our names
I'm
as
gonna think about a
authors.
solution of this later. Let's finish for today. I think we already passed the 2 hour mark. Yeah. So I'm gonna finish the recording